Good afternoon, everyone. My name is Schnaude Dorizan, and I'm a graduate student here in the Neuroscience department at Northwestern University. Today, I have the pleasure of discussing with you my project, the development of a rabbit model of memory improvement. Now, we've all been in a situation where we've forgotten something. Car keys at work, the password to your Grubhub account, or better yet, you've put a pot of water to boil in the kitchen and you walk away for just a second. You take a phone call or you check your fantasy football league stats, and it isn't until the smoke alarm is blaring in your ears that you remember the now empty pot of boiling water. This happens to everyone. It's very common. And if you're anything like me, it happens every 5 minutes. But it's common. In fact, 1 in 3 people suffer from some form of memory loss throughout their lifetime. Thankfully, this simple forgetfulness doesn't mean that we're all memory impaired. It's just a fact of life. However, it's when this impairment persists and interferes with your everyday activities that it becomes a problem. Memory impairment is defined as the lack of one's ability to consistently recollect information to the extent that it impairs your everyday activities. People who suffer from memory impairment struggle to remember recent events and tasks that they need to perform. They develop these compensatory mechanisms to get around their impairment, but mostly it negatively impacts their quality of life. Now, there isn't just one overall treatment to memory impairment, and that's because it's not just a symptom of one disease, but a variety of diseases and memory disorders. It can also be a result of brain trauma. This poses a challenge to investigators who are attempting to study memory impairment and develop effective therapeutic interventions. One step in the direction of understanding memory impairment, though, is defining memory and figuring out the biological basis in the brain. Now, the hippocampus is a region deep within the brain that is essential for the formation of new memories. One theory states that the hippocampus communicates with cortical regions, or the outer neural tissue of the brain, in order to support memory. According to this theory, the actual contents of memory are stored within the cortex, and these cortical modules that are anatomically linked to the hippocampus are then linked together by the hippocampus when we're remembering things. It is the dysfunction of this cortical-hippocampal network that is implicated in memory impairment. Now, the interaction of these cortical regions with the hippocampus is thought to support associative memory in humans. That is the ability to learn and remember the relation between two different items. It was actually here at Northwestern in the lab of Dr. Joe Voss that they found that they could modify a cortical region within this network in a way that increased the flow of communication between that region and the hippocampus and improved associative memory. Though they were able to show that this modification changed how the network functioned, we don't yet know the mechanism by which this occurs. That's where my research comes in. I want to develop a rabbit model of memory improvement so that we can understand the biological mechanisms that underlies learning and recalling memories. Rabbits can be studied in a way that will allow us to understand the active circuit underlying the cortical-hippocampal network, which will inform us as to how the network actually functions, and then ultimately help us facilitate the development and treatment of therapies for people who are suffering from memory impairment. Now, in order to use the rabbit as a model of cortical-hippocampal network function, we must do 3 things. First, I have to identify the cortical-hippocampal network in the rabbit. Second, I have to evaluate the effects of cortical modification on the overall communication of the network. And finally, I must evaluate those cortical modifications on associative memory function. In order to identify the cortical-hippocampal network in the rabbit, I created detailed maps of correlated function between the hippocampus and cortical regions. Using rabbit brain imaging data, I was able to identify cortical areas that had a really high level of communication with the hippocampus, and then use those areas as targets for cortical activity modification. In order to modify the activity of these cortical regions, I plan to implant an electrode into that region and then stimulate the neurons using electrical activity. This will increase the connection between that cortical region and the hippocampus, thereby strengthening that connection and improving that network function. Lastly, I want to test the effects of the cortical modulation on associative memory function. In order to do this, I'll use trace eye blink conditioning. It's an associative memory task in which the rabbit will associate the conditioned stimulus, or a whisker vibration, with an unconditioned stimulus, such as an air puff to the eye. These two stimuli are then separated by a stimulus-free trace period called the trace. Now, the unconditioned stimulus will elicit a reflexive eye blink response. After repeated sessions of pairing the conditioned stimulus and the unconditioned stimulus, the rabbit will then learn to associate the two, and eventually the conditioned stimulus will elicit the reflexive eye blink response. Now, eye blink conditioning is a model system for the assessment of associative memory because it's well established in both humans and rabbits. So it provides a very nice translational foothold on which we can compare the results across species. I plan to condition rabbits in this trace eye blink conditioning task and record the number of days it takes the rabbit to learn the task. Associative memory would have said to have been improved if the rabbits that receive cortical modification learn this task faster than the rabbits that do not receive any cortical modification. Together, these findings will help provide insight into how the cortical-hippocampal network functions in order to support associative memory. Using these data, we hope to facilitate the development of therapies and treatments based on brain stimulation in order to help people who are suffering from memory impairment. So that pot of boiling water that you always seem to forget, hopefully with my research, you're likely never to forget it again. Thank you.